All right, so we've been talking about multiplying radicals. And we multiplied a single radical by another single radical. We multiplied a single radical by a tuple in parentheses. Now we're going to look at this situation where we've got two radicals in parentheses times another two radicals in a different set of parentheses. How many multiplications do you think? Think back to last year. Yeah, like if I gave you something like this. Four. You have to take the first term in the first set of parentheses, multiply by these two, and then take the second term in the first set of parentheses, multiply by those two. Same with radicals. Exact same thing. Okay. Stop doing that. This is not being very cooperative today. Whoa. Whoa. All right. Good as I can do. Okay, so I'm going to have to multiply 4 root 3 by root 2, and then subtract 4 root 3 times 2 root 7. Then I'm going to have to go back to the first radical, take this first binomial, take the second term, and multiply by every term in the second set of parentheses. So we should be somewhat familiar with this now. What is 4 root 3 times root 2? 4 root 6. Minus 4 root 3 times 2 root 7. 21. Plus 3 root 5 times root 2. It's 3 root 10. Minus 3 root 5 times 2 root 7. Right. Now, just like we did when we were multiplying binomials that had x's or different letters in them, we always want to look to simplify the factor. But before we simplify, we want to see, are there any of the radicals, the square roots in this case, that we can simplify? Are there any perfect squares that go into any of those? No. Which means they're all different numbers under the radicals, under the square roots, so I can't combine anything as far as I can go. From AB, 4 multiplications. Uh, 4 root 2 times root 7. 4 root 14. 4 root 2 times 5 root 14.
20 roots. 28.
That's one that's going to be simplified. Minus 3 times root 7. Well, that's just 3 root 7. Minus 3 times 5 root 14. 15 root 14. So what I'm going to do is I'm going to simplify anything I can first and then collect at the end. You can combine right now if you want and simplify after. It's still going to get the same answer if you do everything correctly. So I don't need to touch the 4 root 14. But this one, I can break it down. So I'm gonna break it down sort of in between the two steps so that I can write the simplified version there. What does it break down to? Root 28. 4 and 7, which further simplifies because the square roots 2 root 7. Which means the second term, if I multiply the 20 and 2 together, I get 40 root 7. minus 3 root 7 minus 15 root 14. And I can combine some radicals because I've got a couple of root 14s, I've got a couple of root 7s. When I combine the root 14s, what do I get? Negative 11 root 14. And when I combine the root 7s, plus 37. And I can't combine those because they have different numbers with square roots of radicals, so I'm done. Okay. The next one is an interesting one because we're going to use it actually when we talk about dividing. What do you notice here? Anything you notice? What do you notice? Same, except, yeah, the signs, right? They're the same, except one's plus, one's minus. Watch what happens whenever we have this situation. We do 4 multiplications. I did before. Root 2 times root 2, and a lot of times, instead of square root, we say root, just to save a little bit of time. So when you hear me say root, you're saying square root. Root 2 times root 2. Root 4. Minus root 2 times 1. 1 root 2 minus 1 root 2, or minus root 2. Plus 1 times root 2. Again. Plus 1 times minus 1. Minus 1. Notice anything? When you simplify, they cancel each other out. Now be careful, simplify word, but root 4, don't think of the highest perfect square. Root 4. Just plain old 2. So it's 2 minus 1, which is 1. Whenever you multiply some binomial by the exact same terms but the opposite sign, the roots will always disappear. Always. And you'll be left with a non-radical number. These two, there's actually a specific name that we use. We call them conjugates of each other. You guys have seen conjugates before when we factor difference of squares. Remember, you factor different squares, you get x plus 1, x minus 1. Conjugates. If you factor x squared minus 25, you get x plus 5 times x minus 5. Conjugates. Okay, the last one we need to be aware of too. And sometimes students get tripped up on this. You are taking both of these terms together. Why are they together? Because they're held by parentheses. And you're squaring them. It does not mean take this and square it, take this and square it. It means take the whole thing. The whole thing, parentheses all, and square it. Which means, again, I've got to do 4 multiplications. So be careful with ones when you're squaring binomials. So again, 4 multiplications. 4 root 5 times 4 root 5. 16 plus 4 root 5 times 3 root 3.
It's 15.
3 root 3 times 4 root 5.
12.
12 root 15. 3 root 3 times 3 root 3. 3 root 9. Let's look at any ones that we can simplify before we collect like terms. What do you notice? It's 5. So this is the same as 16 times 5, which is 80. Yeah. Oh, sorry, 9 root 9. Uh, 12 root 15, 12 root 15, I'm going to be able to combine those after. But I'm not done simplifying. 9 root 9. So this is 3, so it's the same as 9 times 3. 27. Okay, so this is the same as, remember, when a non-radical is beside a radical, it means that they're being multiplied. Hello. And finally, collect like terms. Well, I can collect the numbers. What do you get? 7. And I can combine the root 15s. There's 12 of each. 24 root 15. Okay. What I want you to do for this last example is pair up or triple up and try and figure it out. I will tell you what the word inscribed means. Inscribed means the corners of the white square are touching the sides of the bigger square. See if you can figure this out.
Rotate my head. Yes.
Gotta find x. We know that from the bigger square that half the side length of the bigger square is 4 and 4, so we can use Pythagoras. So a squared plus b squared equals c squared. In other words, 4 squared plus 4 squared equals x squared. 4 squared plus 4 squared is 32. Therefore, x is going to be the square root of 32, which can be simplified. We don't go to decimal with these. Root 16 times root 2, which is 4 root 2. That's one of the sides. So now you use this to find your area and perimeter. Your area of a square is this times itself. So 4 root 2 times 4 root 2. 4 times 4 is 16. Root 2 times root 2 is root 4. This is the same as 2, so 2 times 16 is 32. Don't forget your units. Perimeter. Still confuse these. Is 4 times 4 times 4 root 2, which gives me 16 root 2. Okay. That's good. You guys did well with that. Okay, so all I want you to do for next class, and when I say next class, I mean Monday. I don't know what's happening tomorrow. We'll just play it by ear. Right? So for Monday, make sure all of exercise 1.3 is done. Stay caught up with these exercises, ladies.